Hello, thank you for watching this video. So in this video we're doing question 8 of May, June 2023, question paper mathematics paper 2. And the topic is cyclic geometry, as you can see over here, or Euclidean geometry if you want to call it. So let's go. At 8.1 they're saying in the diagram O is the center of the circle. K, T and L are points on the circle. KT, TL, KL, OK and OT are drawn. OT intersects KL at M. ST is the tangent to the circle at T. They went on to say that angle T, which is the angle formed by ST and TK, is equal to 36 degrees. And angle K, which is the angle formed by OK and KL, is equal to 18 degrees. So this is the diagram here. They are saying O, which is O over here, is the center of the circle. They are saying K, T, and L are points on the circumference. So they are points on the circumference of the circle. Fine. They went on to say that KT, TL, KL, OK, and OT are drawn. So just these lines are drawn there. They went on to say that OT intersects KL at M. OT, this line OT, intersects the line KL at point M over there. They went on to say that ST is the tangent to the circle at T. There's a tangent, ST is the tangent to the circle at point T. Fine. They went on to say that angle T, which is the angle formed by ST and TK, is called 36 degrees. Angle T, which is your T1 in this case, which is formed by ST and TK, is called 36 degrees. And angle K, which is the angle formed by OK and KL, is called 18 degrees, which is angle K, the angle formed by OK and KL, is called 18 degrees, as you can see over there. Fine. So I've done a session on Euclidean geometry. If you can go to my playlist and check bed action sessions there, you will see I've taught the geometry from first principles really, and I've proved almost everything that I think you need to know. So everything that I'm doing here, everything that I will do at 8.1, I've covered it already. Maybe 8.2, which is proportionality, not very much, but let's go. They are saying at 8.1.1, determine, giving reason, the size of T2. So they want us to find the size of T2. Where is T2? T2 is this angle over here. So they want us to find T2. How do we find T2? So T2 is between OT and TK, right? No problem. So in order to know what T2 is, this is what you need to remember. So when I was doing geometry sessions, if you had a circle like this, and let's say you have a tangent here at this point over here, and let's say this is the center here, center O. This line from the center to the circumference is called the radius, right? The line, this is your tangent, it touches the point at one, it touches the circle at one point, at exactly 1 point. So what I taught and proved, I proved that the radius is perpendicular to the tangent. I've proved that, which is the angle between the radius and tangent is always 90 degrees. I did on my bed action sessions where I was teaching geometry, I did prove this theorem, that if you have a tangent to the circle and you draw a radius from the center to the point of contact or to the point of tangency, then the radius and the tangent will be perpendicular at that point. So the angle between the tangent and the radius is always 90 degrees. So in this case, T2 is not an angle between, is an angle between the radius and this chord TK or KT. But it's not the angle between, T2 is not the angle between the radius and the tangent. But T1 and T2, if you add T1 and T2, it will give you the entire angle. So this angle T1 and T2 is the angle between now the radius and the tangent, right? So you know that the angle between the radius and the tangent is always 90 degrees because the radius is perpendicular to the tangent, which is what I'm talking about. I did a proof for this on my bed action sessions. Go to my playlist to see what I'm talking about. So in this case, we know that if we say T1, angle T1 plus angle T2, if we add this angle, both of them, they should give us 90 degrees. Why? Because a tangent, what is our tangent in this case? We can say our tangent ST is perpendicular to the radius. What is our radius? Our radius is OT. I did a proof for this. But we know T1. Angle T1, we're given T1. What is it? It's 36 degrees. But we're missing what? T2. Which is we can substitute 36 degrees here and find T2. So in that case, we'll have 36 plus your T2, which is what we're trying to find, is equal to 100. It's equal to 90 degrees. Right? Therefore, your T2 is equal to 90 minus 36, which should be around 54 degrees. There's your T2. It's equal to 54 degrees. So in this case, we're going to say, okay, angle T2 is equal to 54 degrees. That's where we are. Done with A. Let's go to B. What do they want at B? They want you to find angle L. Where is angle L? Angle L is this angle over here. Right? No problem. So, in order to find angle L, you also need to know your tangents. I did tangents as well on my bet action sessions. Go to my playlist and look for bet action sessions. If you start from scratch and watch all of them, you should be fine with geometry, at least with grade 11 geometry for now. Because I haven't done grade 12 yet, because I haven't had grade 12 students maybe. So, now we want angle L. So what you need to remember is that, let's say you have a circle like this, and let's say maybe you have a, I don't know, maybe a triangle like that there, right? And let's say you have a tangent here, this point here. Let's say you have a tangent there. What I'm going to talk about is a theorem that we call the Tan-Chord theorem. I proved this theorem as well. And I think I used about 3 cases when I was doing it. So, what is this Tan-Chord theorem? This Tan-Chord theorem says to you that an angle between a tangent and the chord is equal to the angle that the chord subtends on the other segment. So which means if you're looking at this tangent of yours, this is your tangent, right? And this is your chord. This is a chord here. So they're saying the angle between the tangent and the chord is equal to the angle that this chord will subtend on the other side. The angle between the tangent and the chord is equal to the angle that this chord will subtend on the other side. So if you're saying this angle here is theta, the angle subtended by this chord will be theta as well. Come this side. Here's a tangent, here's another chord there. So which is the angle between the tangent and this chord will be equal to the angle that this chord subtends on the other side. So if you're saying this angle here is beta, which is the angle this chord of yours will subtend beta on the other side. That's the Tan-Chord. So, look now. This angle L is formed by KT, right? This angle L is formed by KT over there. Fine. Now, what you need to know, apply that. The angle between this chord and the tangent, right, is equal to the angle that this chord subtends on the other side. So, the angle between the tangent and the chord, you said is 36 degrees, which means this chord of yours will subtend 36 degrees on the other side. That's a Tan-Chord theorem. That is a Tan-Chord theorem. So, the angle between a tangent and the chord is equal to the angle that this chord will subtend on the other side. So, which means the angle between the tangent and the chord is 36. So, which means the angle is also equal to 36 because of the Tan-Chord theorem, which is what I just explained there. So, in this case, we'll say angle L, which is our angle L here, is equal to angle T1, right? Equal to angle T1, and it's equal to 36 degrees. Why? This is the Tan-Chord theorem. Say tan, what is our chord? Tangent. Tangent ST, chord. What is our chord? Our chord is, that subtends this angle L is KT. KT. That's it. We're done with this. So we know our angle L is equal to 36 degrees. Fine. What do they want at C? At C, they want us to find KOT. So they want us to find angle O. What is this? Where is this O? This angle O that you're looking for is between KO and OT. That's how to look at this angle. That's how to read those things. We're looking for angle O formed by KO and OT. Let's go and look for it. Where is KO? KO and OT, which is you're looking at this angle at the center here. Because KOT, angle O formed by KO and OT, which is KO and OT. You're looking for the angle at the center. You know that the angle at the center is twice the angle at the circumference. You just found that the angle at the circumference is 36, so this one is going to be twice that. So you say your angle K, your angle O is called 2 times angle at the circumference. The angle at the circumference is L. So angle at the center is called twice the angle at the circumference. Because you can see that angle O and L are subtended by the same chord KT, which is the angle at the center is 2 times that at the circumference. So the angle at center is called 2 times angle at circumference. So which means your angle O is equal to 2 times angle L, which is 36. So this is about 72 degrees. That's where we are. So we get that this angle over here is equal to 72 degrees. That is, you see. Now we move to 8.1.2. Okay, so now we're doing 8.1.2. 8.1.2, they're saying prove, giving reasons that Km is equal to ML. So they're saying prove that Km is equal to ML. Where is Km? Km is from here to here, and ML is from here to there. So they want us to prove that this is equal to this. Right? They're saying prove this is equal to this. So there are multiple ways you can approach this, but I think the easiest, if you want to prove that this Km is equal to ML, if we can show that this line from center is perpendicular to this chord, then you know that it bisects the chord. A line from circle center perpendicular to a chord bisects the chord, which is this splits your chord into 2 equal parts. Which means if this line is from center and is perpendicular to KL, that would mean that M is the center of KM and ML. A line from center perpendicular to a chord bisects the chord. That's one of the theorems that I did. I think it's the first theorem. I think it's theorem 1A. I proved the theorem. So if you can go to my bed actions again and watch that series, you will understand that a line from center to perpendicular to a chord bisects the chord, which is this will be equal to that. I explained it to detail. So in that case, if you can show that this angle over here is equal to 90 degrees, then we will have shown that OM is perpendicular to KL. Therefore, these 2 lengths should be equal. So let's go. What I will do is, okay, let's look in triangle OKM. In triangle OKM, right? If we add angle O and angle K2, and this angle M here, right? And this angle M, what do we call? I don't want to say M1. Let's just say angle M formed by KM and MO, which is, I'll say angle KMO. It's called 180 degrees. If you add this angle, and this angle, a triangle, it will be 180 degrees because these are interior angles of a triangle. So just say some angles in a triangle, right? So angle M is formed by KM and MO. KM and MO. So let's go and find this angle there. If you find that angle is 90 degrees, then we have shown that we have a line from circle center perpendicular to the chord. Therefore, it will bisect the chord, which means your KM will be equal to your ML in that case. So okay, we just found it to be what? To be 72 plus K2. What is your K2? It's 18 degrees plus KM. It's equal to 180. If you add these two, you find that this is 90 plus angle M is equal to 180 degrees. Therefore, the angle M is equal to 90 degrees. So we have shown that this angle over here is 90, right? So now, in that case, you have a line from center perpendicular to a chord, so it will bisect the chord, which is, it will split your chord into two equal parts, or it will pass through the center of that chord. So we are safe to say now, therefore, our Km is called ML. Why? Because we have a perpendicular line. Yeah? We have a perpendicular line from circle center. So it will bisect the chord. It will split that chord into two equal parts. So if you say Km is called ML, we should say this part is called that part. So that chord Km is split into two equal parts. And I believe we're done with 8.1. So I'm going to clean the board and I'm going to do 8.2. I hope it was clear. Okay, so now we're doing 8.2. At 8.2, they're saying, in the diagram, triangle RDS is drawn. A, B, and C are points on RD, RS, and DS respectively, such that AB is parallel to DS, and the ratio of RB to BS is 5:3. DC is equal to 20 units, and CS is equal to 12 units. So they are saying in this diagram, triangle RDS is drawn. You can see this big triangle here. So they wanted to say that A, B, and C are points on RD, RS, and DS respectively. So such that AB is parallel to DS, and RB, the ratio of RB to BS is 5:3. So they are saying that A, B, and C are drawn on RD, RS, and DS, as you can see here, right? And that's telling you that this AB of yours is parallel to what? To DC, is parallel to DS. So AB is parallel to DS, which is this entire length here. That's what they are saying. So at 8.1.1, they are saying prove given reason that BC is parallel to AD. So they want us to show that this length here, BC is parallel to AD. No problem. Before we even go far, we are told something that I think is important. They have told us that the ratio of RB to BS is equal to 5:3. So what does this mean in a mathematical sense? In a mathematical sense, they're saying RB over BS, which is RB over BS. RB over BS equal to 5/3. Equal to 5/3. So which means if you take the length of RB and divide it by that of BS, the answer that we will get is 5/3. Now, the question becomes, is RB equal to 5 units? Not in general, not always true. Is the length of BS? Not in general, right? So it's not generally true that the ratio is those numbers that you can see there are the exact same length of the corresponding sides, right? Of the corresponding quoted sides. So if you're saying RB over BS equal to 5/3, doesn't mean RB is equal to 5 in general or BS is equal to 3 in general. So the way you can think of this, you can think that 5/3 is the simplest ratio between the length of RB and that of BS. So what you can think of it as some sort of your RB maybe was equal to maybe 5 times A, where your A is a number, and your BS is equal to 3 times A. And then when you took the ratio of those two, the A is cancelled out. Because if you take if you have your 5A here and your 3A here, the A's will cancel out and you'll be left with what? You'll be left with just 5/3, as you can see. So this is how I look at these things. I look at these as some sort of ratios, right? So it's a ratio. These two lengths, original lengths, simplify just to that. So I would say the real length of AB of RB was equal to 5 times A, whatever the value of A was, and the length of BS was 3 times A, whatever the value of A was. If maybe the length of RB was equal to 5, which is our A is 1, and our BS is 1 as well. So that's how I look at it. Fine. So what do they want us to prove? They want us to prove that this BC, BC is parallel to AD. That's what they want us to do. Show that BC is parallel to AD. Fine. You know by now, to prove things, lines that are parallel. For the longest time, before you did proportionality, you would prove maybe alternate angles are equal, corresponding angles are equal, or co-interior angles are supplementary. Those were 3 ways. Those are the 3 tools that you had to prove in order to prove that 2 lines are parallel. You had to prove alternate angles are equal, corresponding angles are equal, or co-interior angles are supplementary. So those are the methods of showing that 2 lines are parallel. Fine. But now, since you have done proportionality, things get, you add more. Let's not say tough. You add more stuff. For example, I'm going to talk about proportionality theorem. They're saying that if you have a triangle ABC and you join 2 sides of your triangle, right? And join 2 sides of a triangle, such that the ratios of corresponding sides are equal, then this side will be parallel to that. So this is the converse of the proportionality theorem. So let's say proportionality theorem converse. Say proportionality theorem converse. So if your AB, your AD, let me start saying, in triangle ADE and triangle ABC, if your AD over DB, right? If your AD over DB is equal to AE over EC, then your DE is parallel to what? To your BC. That's what you need to know. If you draw a triangle and you join 2 sides by a line, such that the ratio of this to this is called the ratio of this to that, then those 2 triangles are proportional. Sorry, those 2 lengths, your line segment dividing your triangle will be parallel to the 3rd side. Because your DE joining 2 sides of the triangle, if it joins it such that you have this proportionality of sides, then that joining line will be parallel to the 3rd side, which is what we're saying here. That's the converse of the proportionality theorem. That is your converse of the proportionality theorem. Okay. Now, it doesn't have to be necessarily this ratio over that one and this. As long as the ratio of the corresponding parts is the same, then the proportionality theorem will work. Which is, it could be this ratio, then the same outcome will be an outcome, or the same or this outcome will be true. Now, what is the proportionality theorem? So now let's go to the proportionality theorem itself. Right? Okay. In this case, you have a triangle. Triangle A, B, C, right? And you have a line joining 2 sides of the triangle, D and E. So it joins, you have triangle ABC, and you have a line DE joining 2 sides of the triangle, such that this line is parallel to that. So you are given that this line is parallel to this. There, you are only given that the corresponding ratios are equal. Here, I'm telling you that this side is parallel to this. Then if this is true, then the ratios will be equal. So, the proportionality theorem says that if you are given a triangle, and on that triangle you divide 2 sides with a line, and you have a line that joins 2 sides of that triangle, such that that line is parallel to the 3rd side, then the ratio of the corresponding parts will be the same. The converse, it says that if I give you the triangle and you join 2 sides of the triangle such that the corresponding ratios, or that line divides the two sides proportionally, then what will happen is that that line will be parallel to the third side. So, in this case, for the proportionality theorem, what do we have? We have that in triangle ADE and triangle ABC, what you have is that if your DE is parallel to BC, then the corresponding ratios are the same, which is your AD over BD over DB will be equal to your AE over your EC. So look at this. These are not the same things. They are inverted. So this is the proportionality theorem, and that is the converse. So in this case, they want us to prove that BC is parallel to AD, which they want us to prove this line is parallel to that line. So if you can apply we want to prove the parallelness of lines. If you can apply the converse of the proportionality theorem and show that the ratios of the corresponding sides are equal, then we will have shown that. Because look at triangle SCB and look at triangle SDR. Triangle SDR, this big triangle, is divided by BC. So you have triangle SDR. This big triangle SDR is divided by BC like this. So what the situation that we have is similar to this or similar to that. So we have a triangle that has been divided. But look now, no one said that this is parallel to the third side. But if you can prove that this is parallel to the third side, then this will also be parallel to this. So in that case, if you can show that the ratio of these sides is the same as the ratio of the other sides, then we will have shown that this is parallel to that, because this line BC will be dividing the two sides of the triangle proportionally. Therefore, if it does that, which means that BC is parallel to your AD. Right? Okay. So what we need to do at this point, we need to say, okay, in triangle SCB and triangle SDR, let's find the ratio of this and compare to the ratio of that. If these two ratios, this ratio of this to that and the ratio of this to that, are equal, that means this is parallel to this. The same way you are saying that this is equal to this and this is equal to this, which means these two are parallel, which is that. Right? So in this case, it was okay. I'm cleaning this maybe. I don't think maybe we might need it. I'm going to say, okay, in triangle SCB and triangle SDR. SCB, SDR, right? If we say, let's say SC, which is SC over CD, SC over CD is equal to SC is equal to 12 over CD, which is 20. Right? Punch that on a calculator. What is 12 over 20? 12 over 20 is equal to 3 over 5. Right? No problem. So you said this part over this part, which is on the other side will be this part over that part. Because this part, this side corresponds to that, this side corresponds to that. So in that case, let's go and find SB over BR. So SB is equal to 3A and your BR is equal to 5A. So this is equal to 3 over 5. So you can see that these two ratios are equal, right? So this ratio is equal to this ratio. If the two ratios, if there's a line that splits two sides at same ratios, that line will be parallel to that side. So we'll say, okay, therefore, our SC over CD is equal to SB over BR, right? They're both equal to 3 over 5. Therefore, which means your BS your BC is parallel to the entire length there, RD, right? Why? Because we'll say line segment, the line, we'll say the line BC divides two sides of a triangle proportionally, right? Or if you want to say, you can say this is the converse of what? Of proportionality theorem. You can say this or that. So therefore, which is your BC, if your BC is parallel to RD, right? You can say that AD is part of RD, which is your BC, will also be parallel to AD, which is what they wanted you to prove over here. And we're done with 8.2.1. Now we move to 8.2.2. What are they saying at 8.2.2? At 8.2.2, they are saying if it is further given that RD is equal to 48 units, calculate, giving reasons, the value of the ratio of AD to AB. So they are giving us that RD, this length from here to here, is equal to 48, right? So they want us to find the ratio of AD to what? To AB. This is what they want us to find. So what we have proved so far, the first question, we have proved that this is parallel to that. That's what we proved from the first question. These two are parallel. So if you're looking at ABCD, ABCD is a parallelogram. So they want us to say, to try and find the length of AB and divided by, of AD and divided by that of AB, right? What is AD? AD is this length over here, and AB is this length over here. So, because this is a parallelogram, right? Because this ABCD is a parallelogram, this length is equal to this length, and this length here is equal to that length over there. So they want us to divide this side of the parallelogram by this side of the parallelogram, right? But we know DC is 20, which is equal to that, right? DC is equal to 20, which is equal to that. So which means we know that AB will be the same as DC, because the opposite sides of a parallelogram are equal. Think of a square, for example. A square is a parallelogram because each pair of opposite sides square is a parallelogram, and you know for a square that the pair of opposite sides are equal. A rectangle is a parallelogram, a rhombus is a parallelogram, and all other stuff that are parallelograms, right? No problem. So in this case, you can say A, B, C, D is a parallelogram. Why? We can say this because the opposite sides are parallel. Let's say both pairs. I'm trying to write both pairs of opposite sides are parallel. That's why we're calling it a parallelogram. So in that case, we can say therefore our AB is equal to DC, and they're both equal to 20 units. So we know that AB is 20. Let's go and find AD. Where is AD? AD is this length over here. So I said that look at the proportionality theorem. We say that if ABC is a triangle and there's a line DE that is parallel to this side, joining two sides, then the ratio of this is equal to the ratio of this side to this side, the same as the ratio of this side to that side, right? That's what we're saying here, because we're saying DE is parallel to DC, therefore this ratio will be the same as this ratio. If this ratio, the ratio of AD to DB is the same as AE over EC. So does this mean this and that is equal, or this and that are equal? Not in general. So I said, when I was writing here, which is not clear. So in that case, look, R in triangle RDS. You can see AB is joining two sides of that triangle and is parallel to the third side, which is this length, this ratio over this ratio. The same is this ratio over that ratio over there. Right? So we can say, look, in triangle RDS and triangle RAB, we can say RA over AD, right, is equal to RB over BS. Why? You can say this is a proportionality theorem, right? Because what? Because your AB is parallel to DS, right? We were told this. So now we know that we know that RB over BS is equal to 5 over 3. So RB over BS is equal to 5 over 3. So, which means this ratio as well is equal to 5 over 3. Right? Which means we said that we allow this to be 5A over 3A, right? Because we said, let's say the real length are 5A and BA. So which means for your RA over AD, we can say this is 5B over 3B. Because I don't want, but the ratios are both equal to 5 over 3, this ratio, not, because you see this will cancel out. So they're both equal to 5 over 3. But I just want to stress that they're not necessarily equal. So I'll say this ratio here is equal to 5A, sorry, it's equal to 5B, and this one is equal to 3B. So if you take the ratio of this to this, 5 over 3, this to that, 5 over 3. So all these ratios are equal, which is, we can just say equal here. They are all equal. Right? No problem. So what we want to find our AD. But look now, your RD is made of AD and RA. So I'm going to clean maybe the top part here. Maybe I can clean the entire thing, but I'm not sure what I'm going to need. Yeah, maybe. Let's clean the entire thing, because I think we're nearly done here. Okay, so look what is happening. Look at your RD. RD, which is this entire length here. RD is equal to RA plus AD, which is what we want. RD is equal to what? RD is equal to 48. RA is equal to 5B plus AD, which is 3B. So your 48 is equal to 8B. So divide by 8, divide by 8. So you get that your B is equal to 6 units. Your B is equal to 6. So which means you know that your AD, which is what you want, is equal to 3 times B. Your B is equal to 6, which means your AD is equal to what? It's equal to 3B, which is 3 times 6, which is equal to 18. So you have your AB to be 20, you have your AD to be 18. So you want the ratio of the two. Let's say you say AD, want AD to what? To AB, right? Which is equal to, what is your AD? Your AD is 18. Your AB is what? Your AB is 20. But this is not the simplest form. That is not the simplest version of it. So if you want the simplest version of it, you can say this over this, which is AD over AB, is equal to 18 over 20, which is equal to 9 over 10. Therefore, the ratio of AD to that of AB, AD corresponds to 9, and AB corresponds to 10. Here is your simplest ratio. That is your simplest ratio. And we're done with question 8. And I hope it does make sense to you, as it does to me. And I'm going to move to question 9 now, and then question 10, and we'll be done with this paper. Thank you for watching. Cheers.